video will be on section 2.5 on the derivatives of composite functions. Because this section involves combination of derivative rules, I separated this section into two videos. This video we will learn the concept and solve only problems to understand, and the second video will be me solving complicated problems and different types you might encounter. So composition is a process to combine functions. So if we have two different functions and would like to combine them, which the two different functions are f and g in this case, we denote it in this form right here. And note that whichever function comes first, the second function is applied into that first function. So let's understand what I mean by that with an example. So for this question, you have fx equaling to root x, and my gx given is x plus 5. What we do here, remember that when we were plugging in a number, let's say like x equaling to 4, we were trying to find it at that point. What we did was plugging in 4 to the function, meaning plugging in 4 to the root, right? So here is the same idea. For part A, we can see that I have f g to the 4, right? What I do is I start from inside first, because my g is a function, it's not a number, but I know what I need to plug in, which is 4 for x value. So I go ahead and do g4 equaling to 4 plus 5, which will give me the value of 9. So now I can actually plug in 9 for the f value, and I don't have to deal with the whole equation. So now I'm going to say f9, and I'm trying to find that, and I know my f is root x, so that's going to be root 9, which is 3. So now for the second one, it's the same idea, but instead of g being inside, I have f. So what I do, I start from inside again, I plug in 4 for my x value, my fx. So when I do that, I'm gonna have f4 equaling to root 4, which will give me 2. So now I go ahead and plug in this for my outside function, which is g. So I'm trying to find what g2 is. So plugging in 2 for my x value, I get 2 plus 5, which will be 7. Now, if it doesn't give you any value to plug in, this basically means you do the exact same thing, but just without any number. It's just not easier. So what is my gx? My gx is x plus 5. And I can't simplify further, that's all I have. Then what I do is I take this x plus 5 and plug it into my outside function. So what's my outside function? My fx is root x. And since I'm plugging this as my x value, like we did over here and over here, what we do is I say my x is x plus 5, which is the same thing as saying gx, and that would give me root x plus 5, and that will be your answer. Same thing with this one, but now I have fx inside, which means that my fx is actually root x, so this is the same thing as saying g root x. So for the root x, I go ahead and plug in root x for my x value in gx, because that's the function I'm trying to plug in root x to. Then I'm going to end up with root x plus 5. So now that we are familiar with composite functions, we can learn now how to take the derivative of composite functions. This method is specifically called the chain rule. If your composite function is in this form right here, the derivative would be taking the derivative of the outside function first, keeping the inside same, then taking the inside derivative function and then multiplying it. So let's try to understand what I meant with a problem while taking the derivative. So for this, it wants me to differentiate x squared plus x in a bracket to the power of 3 over 2. So you might be saying it's not really in this form, I don't see it that easily, but you can also think of this, that whatever is inside the bracket is a function. So I can actually call this gx, right? And if you remember, whatever the gx is, if you put it inside of the fx, when you're doing that, so in order to put it inside, we plug in into the x value. So technically this gx is plugged in to the x value of f. So my fx is actually x to the power of 3/2. So now I know what my two functions are. So I'm going to go ahead and take the derivative of both first. So when I'm taking the derivative of fx, I can see that I can apply the power rule, which I have n value right over here of 3/2. So I'm going to bring that 3/2 to the front, put x the same, and then do -1 to my power, which comes to the same thing as saying 3/2 minus 2/2, which will give me 1/2. So this is going to be x to the power of 1/2. Now I'm going to take the derivative of gx. I see that I have x squared over here, which I can apply power rule again, bring n value, which is 2, to the front, put x the same, and do -1 to the power, which is 1. I'm not going to rate it. For my x value, remember this is to the power of 1. So if you bring that to the front and do 1 minus 1, you're going to end up with having x to the power of 0, which just cancels out being 1. So I'm just going to write +1. So I'm going to end up with 2x plus 1. Now I will go ahead and use my formula right over here. So I'm going to take the derivative of fx, which is right over here. I'm going to write it as is. So I have 3/2 x to the power of 1/2. But remember, my gx is inside, which means it's in the place of x. So what I'm going to do is take x squared plus x as it is and do to the power of 1/2. Now I'm going to take the derivative of gx over here, which I already did. So this is times 2x plus 1. And that would be my answer. So what we did in the previous question is also known as the power of a function rule. So if you have a function like that where u equals gx and your gx has a power of n, you can actually take the derivative by taking the n to the front like the power rule, keeping the gx the same, doing n minus 1 to the power, and taking the derivative of gx. It comes to the same thing as this, but just so you know, for here, that's exactly what we did. We said here is gx, and here is my n value. If I applied the power of a function rule, it will be easier for me, because all I need to do is take the n value, which is 3/2, put it to the front, keep gx the same, do -1, which is 2/2 to the 3/2, and I'll end up with 1/2, and take the derivative of gx, which is inside, and I'll end up with 2x plus 1, and which is the same answer we got previously. So if we want to apply the chain rule in Liminal's notation, if y is a function of u and u is a function of x, so that like your y is going to be a composite functions, then your dy dx, which is when you're taking the derivative, would be separated into dy over du times du over dx, provided that both needs to be existing. So let's try to understand that by a question so it might make more sense. When it says y is a function of u, it means that if you have an equation y that is in terms of u, and u is a function of x, meaning you have u which is in terms of x, so that your y is basically a composite function because it includes both u as the function inside of the y, then when you're taking the derivative, it would be dy over du times du over dx. What it means when we say dy over dx, when we're taking the derivative in Liminal's notation, is basically when you're taking the derivative of y in terms of x. So if you look at here, my y is actually in terms of u, it's not in terms of x. So in order to convert that to dy over dx, that's why we separate it into two, saying dy over du times du over dx, because if you realize it, these are going to cancel out at some point to give me dy over dx. So first thing I'm going to do is I'm going to start by taking the derivative of y in terms of u, like it said. So basically all you need to do is take the derivative as we did before. So for u to the u cube, I see that my power is 3, and I can apply the power rule to bring that 3 to the front, keep u the same, and do -1 to the power, which will give me 2. And then I have minus 2u, which I know this u has a power of 1, and I know whatever it has the power of 1, it just gives me 1. So now I have -2. Anything taking the derivative of a constant will just give me 0, so you don't have to write it. So your first portion is basically done. So now for the second one, meaning times du over dx, is basically saying take the derivative of u, which is in terms of x. So I see that my u is here, and it is in fact in terms of x, so I'm going to take the derivative of this. So I'm going to do times, your constant is going to stay the same. Anything root x actually is in the form of x to the power of 1 over 2, which I can apply power rule. So I'm going to do times, bring 1 over 2 to the front, keep x the same, and do -1 to the power, which is -2 over 2, and that would give me -1 over 2. So I just put that in. Now I can simplify it further. Now I have 3u squared minus 2, and then times 2 times 1 over 2 is just going to give me 1, because these just cancel out. So I have x to the power of -1 over 2. Now to continue the problem, I see that it wants me to find the derivative at x equals 4. All I need to do from here is plugging in 4 for my x. But I realize I have u, but you don't really need to write it in terms of x for everything. But I can plug in my u given over here to my function. So I can say 3 and put whatever the u is. So my u is 2 root x squared minus 2 all over root x. Now I'm going to go ahead and plug in 4. So I have 3, 2 root 4 to the power of 2 minus 2 all over root 4. And now I'm going to end up with 3. And if I take it out of the root, I'm going to have 2 times 2, which is 4 squared minus 2 all over 2. Now if I do that, I'm going to end up getting 46 over 2, which will give me 23. An environmental study of a certain suburban community suggests that the average daily level of carbon monoxide in the air can be modeled by this function over here. So it shows me the carbon monoxide levels, where Cp is in parts per million and the population P is expressed in thousands. It is estimated that 2 years from now, the population of the community will be shown by this function. At what rate will the carbon monoxide level be changing with respect to time 3 years from now? Now, what I have here and what it wants from me is finding the rate, and which I know is it wants me to take the derivative, and it wants the derivative of carbon monoxide level, which is represented by C, but in terms of time. And what I see is for this function, I do have the carbon monoxide, but it is in terms of population, it's not in terms of time. And if I look at this function, it's a population, it shows population, not the carbon monoxide level, but it is in fact in terms of time. And it wants me to find it 3 years from now. So I know that it wants me to take the derivative of the carbon monoxide level, and in terms of time, that's what I'm trying to find. And when it says 3 years from now, it wants me to find it when it's at t equals 3. I know that I can solve this by actually multiplying these two functions over here of their derivatives. So I can say for the first function, it is my carbon monoxide in terms of population, and I do times, and this is my population in terms of time, which I can see that these two will cancel out at some point. The first function over here, I rewrote it as 1 over 2, which means the same thing. And I will take the derivative of that. When taking the derivative, this is my n, which I will bring it to the front. And this is my gx, so I keep it the same first. Then I will do minus 1, which will come to 2 over 2 for this. And I will end up getting minus 1 over 2. So I will rewrite that as negative 1 over 2. And then I multiply it by the derivative of gx. The derivative for that would be keep the constant same, which is 0.5, times take the n value, put it to front, which is the power rule. So I have 2p and do minus 1, which will give me just 1. The constant will just become 0. Anything derivative of a constant will be 0. So for the second part now, it's this function right over here, and I just take the derivative of it. I see that the 3.1 is just a constant, which when I take the derivative will become 0. And over here, I see that I will have 0.1 times, bring that 2 to the front, so I will have 2t. And when I do minus 1 to do 2, I will just get 1, which I want right in. So now that I have my function, all I need to do is plugging anything for p, that it just cancels out. So I know my t value should be 3. So what I can do is plug in 3 for this and find the value and then plug it back for the p value. So when I do that as an answer, I will just get 4, which I can plug it back into here. So I will do 0.2, plug in the t value, which is 3 over here. And my p value is now 4 over 2 root 0.5. What is my p value? It's 4. So I'm going to do 4 squared plus 17. Now as the answer, I will get 2.4 over 10, which will give me 0.24 as an answer.